Hey there, Mr. Sutton here with the Pre-Cal Honors 3-3 Extra Practice Number 1 solutions on adding and subtracting rational expressions. To subtract these rational expressions, we first look to see if we have the same denominator. We do, both 15s. So we have a denominator then of 15 that we're going to just keep. And then for the numerator, we'll just subtract the numerators up here. So 11x minus 2x leaves us with 9x up there. And now I always check to see if I can reduce after I add or subtract numerators. 9 and 15, those can both be reduced by 3. So I'll reduce the 9 then to just 3. And the 15, dividing that by 3, we have a 5. So when the dust settles, we end up with 3x over 5. To simplify these rational expressions by adding them together, we're going to have to first find the least common denominator, or at least any common denominator. So to do that, let's go ahead and factor those denominators just to see what we're going to have to throw into the LCD. So for this first denominator, we can take out a 2, leaving me with an x plus 7. And for the next one, I can factor out a 10 as a common factor, leaves me with an x and a plus 7 in there. And now to find the LCD for these, let's first start with the coefficients out in front of the parentheses, so the 2 and the 10. So looking at the larger of those, 10, I ask, does the 2 go into the 10? It does. So 10 is actually the least common denominator between 2 and 10. That's not the whole LCD, but 10 is at least kind of the beginning of that. That covers the numbers out in front. So now we look at the other factors. So we're definitely going to need an x plus 7 for this first denominator. And that's it for the first denominator. Now looking at the second denominator, there's also an x plus 7 there, but we've already got that covered by this x plus 7 in the LCD. So this is going to be our least common denominator. All right, let's go ahead now and multiply one or both of these fractions by whatever we need to get the LCD. So for the first fraction, we've already got the x plus 7 from the LCD, but we need a 10 instead of a 2. To get that, I need to multiply by 5, but I can't just multiply the denominator by 5. Got to do the top and the bottom, like so that we're actually multiplying by 1, a fancy form of 1, and not really changing the value of anything. And then for this other fraction here, well, we actually already have the LCD in this one, so we don't need to do anything for that fraction. All right, going back to my first fraction, 8 times 5 gives me a 40 in the numerator. And 2 parentheses x plus 7 times 5, that gives me the 10 parentheses x plus 7 that I was trying to get, the LCD. And then this other fraction, again, is unchanged. We'll just rewrite it. Now, since I've got the same denominator, I'm just going to merge these into one big fraction with just one of those 10 parentheses x plus 7s down there. And now I have to get the numerator by adding the 40 and the 5 together. So that's going to be 45 upstairs. Now 45 and 10, those can be reduced. 45 can be reduced by 5 to be a 9. And then 10, if you divide that by 5, we've got a 2 down there. So then when the dust settles, I have a 9 over 2 parentheses x plus 7. To subtract these rational expressions, we first need a common denominator, which we do not currently have. So to get one, we're going to have to factor those denominators and throw together an LCD that has enough factors for both of them. So for the lower left here, I'm looking for factors of 6 that add up to 5. 1 and 6 doesn't work. 2 and 3 does, positive 2, positive 3. So x plus 2, x plus 3 is those factors down there. And then let's just factor the other one to see what else we're dealing with. So factors of 4 that add up to 4, well, 1 and 4 doesn't work, but 2 and 2 does. So x plus 2 and x plus 2, or I guess you could write x plus 2 squared if you wanted. Half a dozen of one, 6 of the other, I guess. All right, so putting together our LCD. So we've got an x plus 2 in the LCD, but since the x plus 2 appears twice in this denominator, we're actually going to need 2 of those x plus 2s. So we're going to need an x plus 2 squared for our LCD. One way you can think about this, the LCD needs to have whatever you would need to cancel out both denominators. You're not going to be able to cancel out both of these x plus 2s unless you have 2 of them in the LCD. All right, so now we also need, looking at our other factors, this x plus 3. We need one of those in there as well. So this is our LCD. We're now going to multiply one or both of these fractions by whatever we need to get this LCD. So for the first fraction, that one it has the x plus 3. It has one of the x plus 2's. It needs another x plus 2 to get this x plus 2 squared. So I'll multiply by x plus 2 over itself, because we're just multiplying by 1 so that we're not really changing the value, just giving it a makeover. Now this other fraction that we're subtracting, that has the x plus 2 squared basically. We're going to have to multiply that then by x plus 3 over itself to get that other piece of the LCD. All right, let's go ahead now and multiply these things out to see what we can do further with the same denominator. So for this first fraction in the numerator, if I distribute this x to the x plus 2, I've got an x squared plus 2x, and then downstairs I've got x plus 2 squared and x plus 3, basically the LCD that we were trying to get by multiplying by this factor here. Now for this other one, I've got a 2 getting distributed to an x and a plus 3, so that's going to be 2x plus 6, and we're subtracting that fraction still. And then downstairs I again have the LCD. I've got an x plus 2 squared and an x plus 3. All right, so far so good. Since we've got the same denominator, I can now combine these into one fraction with one big denominator of x plus 2 squared, x plus 3. And now I just have to actually combine the numerators by subtracting. So I've got an x squared. There's no other x squareds to combine with that, so I'll just write x squared here. And let's see here, I have a 2x, and I have a minus 2x. That cancels out, so there's no linear term, no x term. And then I have a minus 6, because this minus really gets distributed to that whole numerator. So this is x squared minus 6 when all is said and done. And since 6 is not a perfect square, we can't actually factor this at all. So this is as good as it's going to get. For this problem, we're trying to add these three rational expressions together. So this one's a little bit of a beast. Before we can add these, although they look very similar, if you look closely, we don't actually have any of the same denominator. So we're going to have to get an LCD and turn all these into the same denominator before we can go any further. And to do that, I'm going to have to do a little bit of factoring. So definitely the m squared minus n squared can get factored. So let's go ahead and start over there. Since this is the difference of two squares, we can use our plus minus shortcut. So m plus n times m minus n, basically just square root these and put them in a plus and minus. And this n minus m right here, you might think this doesn't need to get factored, but it actually can be factored a little bit. If you notice, the m comes first in all of these, so it might be nice to have a positive m. So one optional thing you could do here is factor this by taking out a negative 1, and then that would make this m here positive and the n negative, so you'd have an m minus n. Now, the nice thing about doing this, if you look closely, is that there is an m minus n over here in this first denominator. If we were to just leave this second denominator as n minus m, well, now that would leave us with like three different things, right? We would have an m plus n, an m minus n, and then we would have an n minus m. Now, I mean, we still have three different things, but one of them is a negative 1, which seems a little bit easier to deal with. Anyway, lots of ways to do this problem, but let's continue with this way of doing it then. So I need to get the LCD out of all this. So I definitely need a negative 1 in my LCD. That takes care of kind of numbers out in front. I also need an m plus n and an m minus n. So all of that should be in my LCD, in my denominator for each of these. Let's go through now and give each fraction what it needs to get the LCD. So for this first fraction, this one has almost everything it needs. It just needs that negative 1 out in front. So we'll multiply by negative 1 over itself so that we're just really multiplying by positive 1 and not changing the value. For this next fraction, we have the negative 1 and the m minus n. We still need the m plus n, so I'll just rewrite that fraction and then multiply it by m plus n over itself. And then for this last fraction, I've got the m plus n, but now I still need a negative 1 and an m minus n. Okay, so now let's go through and simplify each of these. So for this first one, distributing that negative 1, I have negative m squared minus n squared over negative 1 times all this stuff down here, basically the LCD, which was kind of the whole point of doing this. For this next one, I need to distribute this m to the m plus n. So that's going to be m times m is m squared, and then we're going to have plus mn all over the LCD. And then for this last one, you can think of this as basically distributing a negative n to both of these. So I can write this if I want to. This would be either negative mn plus n squared, or you could write this as positive n squared minus mn. Doesn't really matter what order you write those in, as long as the mn is negative and the n squared is positive. And then we still have the LCD in that denominator. All right, so when all is said and done, we're going to end up with one big denominator with this LCD. And let's see what we end up with in the numerators. So we have a negative m squared. I can combine that with this positive m squared, and actually those cancel out. Well, that's nice. We have a negative n squared, and we have a positive n squared. Those cancel out too. Well, how about that? Well, the only thing left then is this mn and this negative mn, and wouldn't you know it, those also cancel out. So when we add the numerators together, it turns out everything cancels out, which essentially means, since we're canceling by adding, you're getting 0 in the numerator, and 0 in the numerator divided by anything else is going to just come out to 0 for the whole fraction, which is good because we were out of space anyway. For this problem, to add these, I need a common denominator. So let's take care of the coefficients and then the variables. So for 15 and 18, what do those both go into? Well, let's start with the bigger one, 18, and then start taking multiples until we get something 15 also goes into. So let's see, you got 18, 15 doesn't go into that. 36 is the next one, still no good. And after that, we got 54, no good. 72, 15 doesn't go into that. 90 is the next one. 15 does go into 90. So we've got 90 for the coefficient part of the LCD, but we also need the other factors as well. So going in alphabetical order, looks like we're going to need an x in there. And we're also going to need a y squared. Because the y is being squared here in a single denominator, that's why we need a y squared instead of just y to the first power. But now that we've got that y squared, that also covers this y to the first power in the second denominator. All right, so this LCD has everything we need for the factors of both denominators. Let's now multiply each fraction by whatever it needs to get the LCD in the denominator. So for my first fraction, it looks like to get 90, I'm going to have to multiply 15 by 6. And we're also missing an x, so I have to multiply by 6x over itself then. And I'm doing 6x over 6x because I'm really just multiplying by 1, a fancy form of 1, so that I'm not really changing the value of anything. Now for my second fraction, I've got the x. I need a y, though, because I need to get y squared for the LCD. And to make 18 into 90, I need to multiply 18 by 5. So 5y over itself is what I need to multiply for this one. Let's go through now and actually multiply by that. So for my first fraction in the numerator, 6x times 7x gives me 42x squared. And then in the denominator, we end up with 90xy squared, which was the whole idea of what we were multiplying this for. And now for the next fraction, y times 5y gives me a 5y squared in the numerator over the LCD that we were trying to get. Now, since I've got the same denominator, I can just keep that 90xy squared as one big denominator, and now I can add the numerators. Now, since 42x squared and 5y squared are not like terms, I can't combine them. The best I can do is just write 42x squared plus 5y squared. And since there's no way to factor this further or cancel anything else out, this is as simplified as it's going to get. For this problem, we're trying to simplify this rational expression. So it looks like since we're adding a fraction together, and 5, you can consider that a fraction of 5 over 1, we're going to need a common denominator to do this, and we don't have one just yet. But since the only denominator that's not 1 is this 3y, that means 3y is going to be our least common denominator. So let's multiply each thing by whatever it needs to get the LCD. This first fraction, 2x over 3y, is perfect the way it is, so don't need to multiply by anything there. But 5 over 1, to get a 3y downstairs there, I'm going to have to multiply by 3y over 3y. And I'm doing it over itself because I'm really just multiplying by 1 here, so that doesn't change the value. So now 2x over 3y, again, we'll just rewrite that, nothing changed. This next one, though, let's multiply this out. So that's going to be 15y squared over 3y. Since I have the same denominator, I can add this into one big fraction with a denominator of 3y. And in the numerator now, I just add the two numerators, 2x plus 15y. Well, those aren't like terms, can't combine them, so I'm just going to have to leave this as 2x plus 15y. Since I can't factor anything out or reduce anything, this is as far as we can go.